Xin chào. Hi. Hello, everyone. Welcome back to HCLTech Vietnam Tech Talk series. I would like to send my greeting and thanks for your presence in today, the virtual session, heating, ventilation, and air conditioning function and change in HVAC post-COVID-19. And another beautiful Saturday morning is here, one of the days when there is no rush for anything and one can stay back a little longer. But you are here with us, appreciate that. And my name is Mai, Senior Marketing, and I'm your host. But now we are waiting for more people to join.
Progress. It comes from having a clear objective, a goal, moving forward unwaveringly towards success. It can be fast, it can be slow, it can be disruptive, but one thing it can't be is stopped. While progress might seem inevitable, breakthroughs come from supercharging it, delivering business outcomes at scale, fulfilling aspirations with compassion, innovating responsibly, finding new levels of efficiency, removing barriers, unlocking potential. Business is always moving, so it's easy to confuse motion with real progress. Whether it's day-to-day success or transformational gains, we supercharge progress to change the game. HCLTech, supercharging progress.
Welcome back. I know a lot of you here have attended our webinar before, and surely you already know about us. But for people who are newcomers, I'm gonna show you more about HCLTech Vietnam. HCL Vietnam started over a years ago, and as on date, we are located in two locations, Hanoi and Ho Chi Minh City. We are serving 30 plus global customers from both the locations, with a diversity ratio of 27%. HCLTech Vietnam has also the successful setup with a university partnership program where we have got over 15 universities. Our focus area for Vietnam is the high-tech area, which also includes digital transformation as a key focus area for us. The domain where HCLTech Vietnam is focusing on from banking, insurance, other financial services, automobiles, and or manufacturing, pharmaceutical, medical devices, CPG, and retail. We recruit people who are experienced professionals in Vietnam. We also look at fresh university graduates and also students who are all undergoing their university education in the 7th and 8th semester. In the next 3 years, HCLTech Vietnam is poised to grow to a strength of 3,000 employees to provide service to clients in various high-tech and cutting-edge technologies. If you have interested in career opportunity at HCL, please visit our website hcltech.com and follow our fan page to find out available jobs. So, attend our virtual session today. We have Mr. Poornateja Maddela, Technical Lead HCLTech, to share the updates on HVAC. I'd like to introduce more about today's presenter. Teja has bachelor degree holder in mechanical engineering. He is Pratibha awarded by government of Andhra Pradesh, India, for the academic excellence in 2015. He also had joined HCLTech in 2015. He has been a part of HVAC design team through the career in HCLTech. Teja currently in Vietnam to build team. He has been a part of designing award-winning world-class products. His hobby is playing chess, and he is a movie buff. And you may send in your questions at any time during the presentations. We will collect these and address them during the Q&A session at the end of today's presentations. And for those who are just joining us, welcome. Now, without further ado, we will turn the time over to our speaker. Um, hi, Poornateja. Hello.
Hi, Mai. Hi,
Yeah.
everyone.
Hi, everyone. So now, please help us to know more about heating, ventilation, and air conditioning, please.
Yeah, sure. And thank you for introducing me to the audience today. Uh, I'll see. I'll make everyone understand whatever I knew. And okay, so welcome everyone. Welcome to the Tech Talk session. Um, I'm very glad that I have this platform to share uh, the knowledge I have, or the knowledge I acquired, or the trends which I saw in current years on HVAC. So I like to talk in this session on HVAC functioning for all of us to understand what goes in it, how does it work, and then talking about some post-COVID trends, because the COVID is a big event which has happened in every one of our lives, which uh, halted our lives. So we need to understand, because we as we grow with the businesses, we have a challenge. We had a challenge in the name of COVID, and we have succeeded to counter it. And we have come up with the new technologies, and we made our businesses move forward. That's what we have done, and so I want to present the same information to each of the audience over here. So if you uh, learn about some of the new technologies that are introduced into the market by entire industry, then my objective for this session is fulfilled. That's what I feel. Okay, so now, um, so Mike, can you go to the next session? Next slide. Yes. So today's agenda for the session would be, we'll be introducing the HVAC industry or HVAC unit, and then we'll talk about we want to talk about function. So we will be understanding what's the science behind the technology, and we'll be talking about technology, and then we'll be talking about pre-COVID situation on the industry, and then how COVID impacted on the industry, and then we'll talk about post-COVID enhancements. I termed it as enhancement because I feel we had everything in our units before. Now we have added extra enhancements to make sure that post COVID effects are achieved. Okay, so this is how I would like to take it. And from my audience, I have an expectation saying, like, I can't we can't tell every bit of the technology and science. So I expect uh, the background would be on physics for each of the audience. Then this talk would help you. Okay, so with this assumption, I'll move forward. So, Mike, yeah. So, uh, so to start with, so this HVAC is a heating, ventilation, and air conditioning. The term HVAC means that, and it's one of the growing business, and this will come under the comforts of an individual. There are two things that a human needs, a human wants. There are needs to um fulfill, and then there are comforts to enjoy. So we started the HVAC as a need, but as a comfort, but it is becoming as a need because of environmental issues. So we will talk about them, but I I want to introduce you all the HVAC from my experience. So the first time I hear about a refrigeration system or air conditioner system was during around late and early 2000s, where the ozone depletion topic was running. So that's where I got introduced to this HVAC world. So as a kid, I learned about the ozone depletion, which affects human beings, and then mm, talking about the cause was CFCs and HFCs that was mentioned, but majorly that was pointed out towards refrigeration systems and air conditioning systems. So that is where I have started understanding it. At the time I felt bad, but that was ignorance because I did not know about the technology. And one of the major event that has happened during that time, uh, pre 2000s, was um, the entire world had a treaty at Montreal to control the substances that are causing ozone depletion. The so here I would like to bring, there are few things where we need to save our environment. We need to keep it available for the next generations. We the environment we are in, we don't want it to be spoiled for the next generation. We want to pass it to the next generation. So that's where all the countries, most of the countries, agreed to use uh, the substances which are safe for ozone depletion. So they should not deplete the ozone. So so uh, this is where I heard about the substances. Whatever substances we were talking about are called refrigerants. So refrigerants are substances that are used into HVAC systems. Okay. So now whatever CFCs, HFCs which are causing ozone depletion, they are a compound chemical substances which are uh, made and which are observed that they possess the refrigeration capabilities. So um, so during that time, there are these two terms, something called ODP and GWP. So ODP means ozone depletion, and then GW is global warming potentials. So we want to use refrigerants or the substances into the system which has lower values of these. We don't want them affecting my system. So during the treaty which you mentioned, during the treaty and then post amendments, we are sorting out or we are phasing out few of the substances usage. So for example, CFCs and HCFCs, which are chlorofluoros and then hydrochlorofluoros, were phased out. So we move to hydrofluoro. So if you understand these terminologies, you will see chloro missing uh, in the later substances. So chlorine was the main culprit. So we are moving towards natural substances to be used in the systems. So this is the introduction for me into the HVAC system. Uh, so I gave few data over here which you can see, which are the next refrigerants that will be uh, used in HVAC system. We have HFCs right now, and then HFCs will also be phased out, expected by 2050, and then we'll have HFOs. And we mentioned I mentioned few of the major refrigerants over here. If you go out and if you buy any unit, most of the units will be having you might be seeing even the units which are produced before, the units which we have now have these refrigerants used. Okay, so the ozone depletion is one thing, and then second thing is the global warming potential also to be looked. So how dangerous the substances are for global warming. So it should not carry heat, it should not radiate the surfaces with the heat it carries. So we will be seeing that also. and as carbon dioxide was always there in the environment, it is considered as lowest level. So from that we'll be comparing and we'll be taking these values. So don't that's how we take the values, and we will always try to find which are suitable for the environment. Okay, so now, so with this, let's get into the HVAC system. What is HVAC system? It's a systematic arrangement of components, and then the running of the cycle, or it is a cycle and systematic arrangement of components which can produce a regulated and conditioned air, uh, and we'll be moving it to the space using that system. We will look into the HVAC systems more. And what is the purpose of a HVAC system? We have, I said, conditioned air. We'll be moving from one space to another space. So when we say conditioned air, there is a term called human comfort comes up, because we create a space with a conditioned environment for humans to use, or to machine to use. We have, with the technology advanced, we have machines which needs which needs a particular space. Otherwise, we need the space for humans. As I said, these are for comforts. These are comforts, not needs initially, but now it's becoming comfort because of environmental issues. Uh, it is becoming a need. Now we need to achieve thermal comfort. So humans like some temperature. If it is too sunny, if it is too cold, we don't feel good. We need a temperature which suits good for our body, and then we don't want more. There is a term called humidity, which mean the amount of water vapor content in your air. So we don't want that content to be high. We don't want that content to be low. So we want it to be in a particular range. So likewise, there are some factors which affect human comfort, which has to be maintained. So we will achieve that conditions using the HVAC system. And then if we maintain that conditions, we don't want the quality of air to be bad. We want to achieve a particular quality. I mean, like we don't want pollutants in the air. We don't want bacteria, viruses in the air which cause health issues. We want it to be clean. So when we say conditioned air, it comes with it has to deal with the comfort conditions, it has to deal with the air quality, and it also has to deal with speed of the air. Because for example, if you go on a road, when a cool breeze comes, you'll feel happy. If air is stagnant, you will not feel happy. So this is a user experience. From there are a lot of tests, experiments done on human experience, and then the comfort conditions are derived. So we need to achieve them by a HVAC system. That's main purpose, to maintain good air quality, and then we need to have thermal comfort, and we need to have proper ventilation also. So we can't have air circulated in the same space after the conditions, like whatever conditioned air is used. If the temperature we want to maintain, if we have maintained, we don't want, if the temperature goes down or goes up, we don't want that air still to be present in that space. We want fresh air which suits for the conditions. So we need to have a ventilation also. That's why this HVAC term is very important. If you observe the term HVAC, we have heating, we have ventilation, and then we have air conditioning. We will be heating, will be air conditioning normally refers to cooling and control of humidity, and then we'll have ventilation systems for proper intake of the fresh air and exhaust of the used air. Mike, can you go to next slide? So I've shown the factors that can affect human comfort. So if we for example, during summer, if we wear winter clothes, we feel suffocated. So vice versa, if we use summer clothes on winter, we'll be feeling cold. So that means the clothing that we wear acts as insulation sometimes, or acts as so the proper insulation has to be there for a human during particular time. So that is a factor that affects. And also the metabolism rate of us, when we work, when we do a lot of activities, our metabolism rate will be different. When we do heavy work, we'll have a lot of energy used by our body. So that also cause discomfort for us. And then we have temperatures, and then we have, I as we said in the introduction, airspeed, humidity, temperature, all of these are factors that affect our comfort. So our comfort is the main priority here. Now, and also I would like to bring up a topic called heat load. We as a the I said HVAC system purpose is to maintain conditions of an air. Um, so I have to remove temperature or add temperature. So that is a major task. So air ventilation, filtration, other things we can use a device and we can do, but we are dealing with conditioning air, increasing and decreasing few of the like humidity and temperature. We want to consider what are the intake for them. So for example, if I have to control temperature, what am I removing, what are the sources of heat? So we need to understand the source of it so that I can remove that amount of heat properly. So I can devise a system which can remove that amount of heat. So without knowing this heat load, we cannot design a system. So that's why this heat load is very important. So a simple picture over here, in a room, for a room, you can understand we get heat from sun, we get heat from equipment, human body can generate heat, we have lights used, they'll generate heat, and then we have walls which gives you radiation after absorbing heat. So, and also we'll have floors and roofs which gives the same heat. So as when you have a room or when you have a building constructed, you need to consider all of these. Or when you have a space, when I say building or a room, it's just a space with a closed boundary or with a partial openings. Okay, so we are conditioning a space, so we need to consider what are the heat that are added up to that space. That's why this is important to us to know. My next slide. So uh, so introducing the system, like the HVAC system, we spoke about purpose. We want to know how we can achieve those things. For example, I have given a slide which mentions which is mentioning science behind the technology. I want to talk about HVAC system, but I want you guys to understand what is the what is the basis for this technology. For example, we are talking about heating. We have heating. We say we need to raise the temperature of air. Let's say heating of an air, raise the temperature of the air. But what principles can be used to increase or generate the heat? So we have exothermic reaction. We should have read it in our younger days. So the chemical reaction which can generate heat. So when we have fuel and when we have oxygen mixed, and then when we ignite it, it'll the chemical reaction happens and lot of heat generates. We'll use that for heating. When we talk about ventilation, the basic principle behind this is law of conservation of energy. We the energy cannot be created or destroyed, and it can only be transferred to another form of energy. That's what we learned. So we have something called Bernoulli's principle in fluid dynamics. So which states, like we don't need fluid dynamics to be learned. If we know physics also, It's a part. It's a basic principle from physics. So where it says the pressure when the velocity or the speed of the fluid increases when pressure decreases. This is the law of conservation of energy, where we are converting. I'm like, if for example, if an air is at stagnant, if it is not moving, it will have a static pressure, some pressure to it. And when you try to move it, the static pressure converts into your kinetic energy, and then you have your potential energy, and then it is converted to kinetic. So that is what when you have a pressure and when you have a speed which is velocity. So your when you increase pressure, it is whatever the velocity will get decreased, so that the total energy is always constant. So the potential versus kinetic is always constant. So with that principle, the ventilation works. And how does it work? Heating, yes, we understand the heat is generated, we'll use it to raise temperature. But this ventilation, with the pressure difference, when you have pressure reduced, the flow will be more, right? So we will be using fans to create a vacuum, so that vacuum will be of lowest pressure, so outer air will tend to move into that space. So that's how the ventilation happens. If we keep a fan at a space where ventilation has to happen, when we when we give centrifugal force to it, so there will be a vacuum happening at the center, and then surrounding air will tend to move in. So that's the science behind it. And then when we come talk about air conditioning, uh, we use thermodynamic cycles. Okay, there are a lot of experimentation happening on gases, fluids, um, before deriving these cycles. Okay, they take a liquid, and they'll test under different conditions how does it behave. So under constant, keeping the pressure constant, keeping the temperature constant, volume constant, keeping different things constant, thermodynamic properties, they will be doing a test, they experimenting to understand the behavior of those gases. And that's how we have thermodynamic processes defined. We observe a process where pressure can be put constant, but properties of other thermodynamic sorry, the behavior of other thermodynamic properties are observed. So such thermodynamic processes are a lot in our thermodynamics. So from them, people could derive the cycle. So they observe that when we combine multiple cycles, and we can form, the starting point is the same as ending point. We can achieve, we can make a gas go into different states and come back to the same state again. So that's how cycles were derived. And one such cycle, later we have the theoretical cycles were brought into practical. So that's how a lot of machines has been produced. And one such cycle that is used to make air conditioning happening, or to cool the temperature happening, is the vapor compression cycle. And one more point I want to say is, it is easy to cool down hot object to the cold object, but we need extra work to be done to bring up the cold object. To move the temperature from cold object to a hot body. When I say hot body, okay, we'll see here. In the vapor compression cycle, I mentioned the processes, the thermodynamic processes over here, and I have shown a cycle over here. So which says the components that you see over there are compressor. From point one, I would like to talk from point one, and then you can follow the arrows for the cycle. We have compressor, condenser, expansion valve, and evaporator. We have formed a cycle, and Each of these process, what happens in compressor, what happens in condenser, each of these are all thermodynamic process. So we use isentropic compression in compressor. uh, Entropy is some concept which says unused, so which is unused and we cannot use it, the energy which we cannot use, it's a disorder. So as we cannot use it, it's a waste energy lying in the system. So the system cannot use complete energy, so it has a degree of, it has a disorderness. So we don't want that to increase. That's why isoentropy means entropy as a constant. So we don't want to make that disorderness to increase. That's why we keep the disorderness constant in the compression. And also we deal with increasing the pressure of gas in the compressor. So when we make gas pressurized, we can't handle it. And also for gaseous as molecules, we cannot handle the entropy, the disorderness will be more. That's why we want to control that entropy in compression cycle. From compressor, we'll have inlet to the compressor will be in gaseous form of of the fluid, and we'll compress it to the high pressure, and then we'll send it to the condenser. uh, when we compress it to the high pressure, it and then we'll send it through condenser. So condenser um, condenser is basically a heat exchanger. The condenser and evaporator which we show over here, they are heat exchangers. Inside them we'll have the fluid which I mentioned. The fluid coming out of compressor will be sent, and then we will try to transfer the heat from it to an external source. For example, we'll keep a fan uh, outside outside condenser, and we'll make air flow through it. So whatever air that passes on the condenser, it takes the heat that refrigerant has in the condenser, and the refrigerant will tend to uh, transform its phase from vapor to liquid. So theoretically, 100% vapor should transform from condenser into liquid when it comes out. And then we have expansion valve, where we want the pressure to come down, but we don't want the total energy to drop. So we will use expansion devices which does this. So the total energy of a system, like the heat that it has rejected, the heat it has rejected, and the transformation, the phase transform it has happened, we don't want that to be lost, because we want to use it in another heat exchanger to gain the advantage of uh, uh, to gain complete advantage. We don't want it to be lost. That's why we'll be having isenthalpic expansion process. So we don't want enthalpy to drop, and then just pressure will be reduced, because we need to handle properly. We don't want our evaporators to work at high pressures, because evaporators are the spaces where human contact will be there. So we'll be having low pressure liquid entering evaporator, and it will be cool. So when we pass air on top of it, the heat from the external air will be absorbed by the refrigerant inside, and then outside air will become cool. So that's how the cycle is. So we'll have vapor entering compressor, it compresses and it gets into high pressure, it will enter the condenser, and as it is in high pressure and it will be in high temperature, as it enters the condenser, it gets cooled and it gets changed into liquid, because of external uh, air pass it through that, and then it goes to expansion device, and then it enters the evaporator. In evaporator, post inlet of the evaporator will be in liquid, and outlet of the evaporator will be completely converted into gas. So this is how the cycle continues, keeps on continuing, and we will be getting cool air from evaporator section. Okay, now so that's the state. My next slide. So that's a science behind the technology, and this is the technology which I want to talk about. So what are the HVAC system requirements? What do we need to have in a HVAC system? We need to have a primary equipment which does this heating or cooling or doing the delivery, which is ventilation. And then we need to have equipment rooms, and then we need to have fan rooms, uh, uh, all space requirement facilities, and then we need to have uh, ducts and terminals. So ducts and terminals are air distribution sections of a system. When we have, I said, we have a cycle. When we arrange the components in that cycle, we get the air achieved, but we need to have a proper path for air to flow. So that is that proper flow path is created by duct. And then the terminals are, we will talk about terminals slightly later. And then we'll be having piping to carry out things. And then one thing which I did not mention in the cycle is, I was keep on saying there will be a fluid inside. So that is a refrigerant which we spoke about in the introduction. So this is the refrigerant, either HFC, CFC, or HCFC. So this is what is been evolving into its close to its natural, close to the natural resource state. Okay, my next slide. So talking about the requirements, we will see some of the furnaces, some of the systems available in our industry. So for heating system, the priority is to raise up the temperature. We use gas furnaces, we use boilers, we use heat pumps, and latest inclusion is infrared heating. And then we have geothermal, we have electrical resistance, and solar heating is also a latest version. Now gas furnace, it's simple to understand. We'll have gas supplied into burners, and then we'll ignite it with addition of oxygen. And then, as we said, the exothermic reaction happens and the heat is generated. Heat will be generated, and it will be a part of flue gas after burnt gas. So we will have the fresh air. Like the air that has to go into the space, pass it through that heat exchanger. So heat exchanger is a tube. Basically, when we burn the gases, we will be sending it through the tubes. Like we will be assigning it a right path. So the flue gases will tend to travel inside the tubes of a heat exchanger, and then outside air will be passed on top of it. Okay, so it is similar to tube and shell heat exchanger. We'll be having flue gases inside the tube, and we'll be having fresh air outside the tube. So that heat transfer happens on the surface of the heat exchanger, and the air that has to go into the space carries that heat and it will go in. So that's how heating happens for the air. And similarly, boiler, when we use water, we'll boil it and we'll generate steam, and we'll allow steam to pass through the heat exchanger tubes, and then fresh air passing on top of it will get heated. So similarly, we have heat pumps. Mike, can you go for previous slide? Yeah. So in the vapor compression cycle, we see that heat is rejected in condenser and heat is absorbed in evaporator, right? So when I say heat is rejected, the refrigerant will get cooled, and then in evaporator refrigerant will get hot. So In both these conditions, we see in condenser, outside around the condenser, it will be warmer. The outside air will take the heat, so it will be warmer. In evaporator, we will get cold air. If we reverse, if we use the application, what we use is the cold space. If we need hot space, we can use the condenser section, right? So for the same cycle, we have uh, two rejection and addition places, which if we just use one into one application, if we use one like which is a hot side, we'll get heating application. If we use cold side, we'll get cold application. So heat pumps are basically reverse to your refrigerant systems. So in refrigerant system, output will be the cold space. In the heat pump, the output will be the hot space. So that's just the heating system. My next slide. Next. Okay, sorry, previous. I'm sorry. So that's one. And then we have inflow radiant heating. On when we construct the homes, this is a recent addition. When we construct homes, the flooring will be we'll be setting up copper tubes in the flooring, and we'll be allowing hot water or hot gas to go in so that it radiates into the surface, into the home. So this is one more thing. And then we have solar heating and geothermal heating, taking heat from the ground and taking heat from the sun to heat our system, heat our homes. So the technology is all similar. The sources of heat is different. Okay, that's the only point you need to understand. Next one, Mike. And then we have ventilation systems. Ventilation system is proper flow of air. Okay, we have natural ventilation systems which is followed from a long time into our homes. When homes are designed, we don't design home as a closed space. We'll keep windows, we'll keep doors for the air to come in, air to go out. We'll be having ventilation. Even if you see old homes, we'll see a open space on the top, or we'll be having inclined surface built with a open ended ends on the top. So similar to what we saw over here. So the air, when the cool breeze comes, it can enter in from one side and it can leave. We need to have that um, so proper intake and then proper exhaust of the used air to be there. So that is the purpose of ventilation system. And we have natural ventilation. If we create an opening on the top, if because hot gas is less intensity, so it will tend to move up. So whenever we get the environment heated up, the air will move up. So that is how people design natural ventilation in old times. So we can use the same system now. And then we have forced ventilation systems where we cannot create a open places. We cannot leave an open space just like that. We'll use ducting. I'm like proper flow of the air. Along with that, we'll be using a external power, for example a fan or a blower, to make the air move out. One good example, we all see ventilation systems in our restrooms. We don't want bad odor to be there, bad air to be there, stagnant. So we'll keep a ventilation system out there. We'll keep ventilation. We'll have a blower in our kitchens where we don't want smoke to be covered over there. So again, as I told you, the science, we'll be creating negative pressure so that the air tend to move on into the negative pressure or even vacuum. Okay, so that is what we do. And then there is a specific units design, something called air handling units, which will handle the inlet air and the exhaust air from the space. For example, if I have a space, I need to send some air and I need to bring out some air. Along with that, with the human comfort condition, which is the air speed, also has to be maintained. We have external forces used like we'll have fans used, and we can condition them. We can take fresh air and we can filter it out, and then we can condition and we can send into the space. So we'll have air handling units designed to do that. Along with that, there is energy recovery ventilation systems added. So when we have outside air taken and inside air coming inside, the temperature difference will be there. We can use some method to extract the heat or extract some energy from exhaust. So that's what energy recovery does. Okay, one example is shown over here where we have exchanger. uh, they'll have they will not they'll not just mix over here. It's the heat transfer or it's energy transfer happens between them. Okay, next Mike. And then we have air conditioning systems. We have centralized ductless and package system. Ductless is most used in our homes. We'll see a small box on mounted to the wall, and we'll see a outdoor unit kept outside. We'll connect it with pipes. So that is very basic example. You can see the ducts systems over here. Sorry, that should be ductless. I think typo. Uh, so they also call mini splits. Okay. And one more thing I wanna point out is during COVID, which is our topic, the sales of ductless systems or mini split systems were very high because people wanted their homes to be cleaner. And then we have centralized system. Centralized system is we'll have conditioned air created in a space, and then we will circulate it to different parts of home. For example, it's a home shown here. We can do it for large space also. Will the conditioned air will be created somewhere, or somewhere, and then we'll keep ducts and we'll give openings to each of the systems, each of the rooms separately, and then the opening from duct into that particular space is what we call terminals. For example, if we have a big house, a 3 BHK, 1 BHK, and 2 BHKs, the volume of them are different. So they need different volume of like a different amount of conditioned air into it. So the terminals are designed such that the right amount of air will be entering. They'll be like a diversion of air along with the right quantity. They will be like branches. Along with they will also decide the right quantity to be entering into the system. Okay, and then we have package systems where all the components will be inside the unit. We have if we see in the cycle, we said 4 components are the main components. Will be in split systems, we'll be splitting outdoor and indoor. Outdoor will have compressor and condensers. Indoor will have evaporator and expansion valves, and we will be placing in the buildings. But in packaged, we'll keep all of them into single. We'll package everything into a single unit, and we'll be using it. Okay, the centralized and packaged are they centralized is split, and then packaged are into a single object. And centralized will have ducts, and then ductless systems will doesn't have ducts. These are the basic difference. Next, Mike. So when we talk about the units, when we talk about how units will be, we need to understand the efficiency also. Efficiency is a must thing to know about the units. And then we have something called COP, which is coefficient of performance. This is this is the term that is equivalent to efficiency in refrigerant systems. So it is basically the cooling energy, which is output, to the work done by the system, which is input. So the ratio of output to input is what efficiency defines, right? So the same. And then now this talks with the work done by the system, and then the cooling output. But we want to make these terminologies simpler for a consumer. So that's where the EER and SEER came into the market. So EER is energy efficiency ratio. So it talks about the cooling output you get versus the electrical input you are giving. So it literally converts into your bills. So how much money you are paying for utilization of electricity in comparison to how much cooling effect you are getting. So it is the ratio of output cooling to input electrical energy. And there are some conditions for energy efficiency ratio. It says if you have a 35-degree outside temperature, which is ambient, and then if you have 27 degrees inside the space, which you need to maintain, if only in these conditions, if you consider how much electrical energy you are utilizing to get this, okay, this is only in that condition the the energy ratio is valid. Okay, and we will be calculating this cooling output for entire year and input energy for entire year, and we'll be taking the ratio. um, when people sell the units, they'll mark EER and SEER. They'll be doing cycles, number of cycles. They'll run the system number of cycles, and then they'll try to get the accurate value. And then SEER is similar to EER, but it's a seasonal energy efficiency ratio. If you see EER, it's throughout the year, but it is considering same conditions always. Ambient temperature is always 35, inside temperature is always 27. In winter, ambient temperature will not be of 35, even it might be less. So in summer, it might be increased. So uh, that's why they define something called seasonal energy efficiency ratio. We will be and also load conditions in winter, people might not use ACs. In summer, most of the people might use ACs if anybody buys AC. Okay, so in that condition, we have to consider how much load we are using from that system, and how how much percentage of times, I mean, like how many seasons, how many months, how many days we are using with that rate. For example, if I'll be using 100% load condition only for 1 month in a year, so I need to consider only that energy for my rating. Okay, so energy efficiency ratio and C are almost same, but C includes all of these parameters. Now, most of the people will try to look at SEER only, because they want their systems defined with respect to close to actuals. Most of the cases, SEER should be more than 17. Many people are trying to achieve that, but we'll see 13 plus will work. But people are trying to achieve SEER 17 and more as a good one. Most of the conditions we'll find between these available, and there are few products which achieve 17. Okay, next one. I'll save this question for I mentioned a question. I'll save this question for the end of the discussion. Next one. So now coming to the main topic, the pre-COVID situation, which I observed or which I learned from. The priorities to HVAC industry pre-COVID, what was the priority? So what do? We build units which we were worrying about sustainability more, the energy conservation, the efficiency of the unit. We design projects, or we design units with that in mind. So, and also we come bring products which are more efficient. If one point I would like to mention is pre-COVID, I don't see any, most of the cases I don't see any purifier placed when I visit a mall. But if you see during COVID and post-COVID, you guys should have seen a lot of air purifiers put into the malls or used by mall stores. I'm just giving an example as a mall because I observed it. So pre-COVID, we were not concerned about that. We were concerned more about energy and then savings and then we were considering consumer experience, like we want to look at our comfort conditions to be achieved. And then we were not giving that much. I'm like all health medical, they were looking into that, but in general people were not considered more into health and safety. I'm like they were not buying units to give them health and safety. They were taking care of that, but not buying units for that. So during that time, as I mentioned, major programs to increase efficiency, and then we were worrying about environment based on the regulation changes on environmental safety. We were doing some modifications. We will be doing if there are any new refrigerants used which are good for ozone and global warming, to avoid them. So we were trying to do the changes, and then we were looking for new technology. There are a lot of research happening in HVAC. We will be including in any new technology we get, and then we'll be doing customization for different customer needs. This is where we concentrated more pre-COVID with respect to our HVAC businesses. Next, Mike. So so that was the situation, and suddenly the event happened. So we had COVID. Um, we had COVID uh, present in with ourselves in our places. So it has become a part. The event happened, and it has become a part. We had to do a war to win against it. So so during that time, if I observe, interestingly, that's a very difficult time for people. But interestingly, HVAC sales increased. So people were worrying about health and other safety issues, and they were buying units. As I mentioned, mini split systems were a lot bought by people. So that's what one thing which has happened, and also awareness to indoor quality has improved. And then we were following safety measures, like we were following distancing, and then we were following non touching the surfaces. So the contact surfaces are avoided by people, and then we have increased the inspection rates for filters and all. So we have taken things seriously, and we were doing some practices which we were not caring before. That's what I want to mention. And also uh, people were constantly looking at ventilation systems which are good, especially medical field. They are looking uh, any medical centers which were not having uh, um, how do I say, the isolation wards. We're trying to build isolation wards. Any homes which did not give proper ventilation, they try to redesign their homes to have more ventilation. So think during the COVID, people tend to change the way they looked at the HVAC industry. They did not opt for that. People who were not opt for that, they were thinking of opting it to get cleaner environments. Okay, so that's what the COVID, during the impact of COVID, people's or that's what the things has changed. Next slide, Mike. So as I mentioned priorities before, now priorities to industry changes. So industry has to focus on customer needs. As customers were thinking more about health and safety, we want to put that as a major considerations. And post that, we have seen a lot of industry runners creating units with clean air objectives. We even if you go to market and see, you will see units with the names which talks about clean air. Okay, so we were pushing, or we were serving that to the customers. We considered energy, we never put we never as health came as an important thing, we did not leave energy, or we did not leave the occupant experience. We still, health and safety is important one, but we try to achieve it within we try to achieve it as a sustainable products only. We want to have health and safety included along with sustainable products with energy efficiency and achieving the necessary needs of the occupant. Okay, and then the area of interest. Now I mentioned enhancements over here because I feel we had everything. We have added these to the existing systems now, and the areas of interest would be on increasing air quality, improving ventilation, and improving the control systems. So these are the areas of interest post COVID into our systems. Okay, next one. So the air quality. When I speak about air quality, we need to understand something called MERV. This is related to filters. So whenever we talk about air quality, all the first term we get is the filtering, the filtration, the filtering of the air to reduce the pollutants, reduce the contaminants in it. So that's when the term MERV comes. MERV is a measurement scale to filter for the effectiveness of it. So we used, as I mentioned, we used medium efficiency filters in our industry pre-COVID. Uh, Now, late post-COVID, as the necessity of cleaner air is increased, we try to include high-cost HEPA filters or HEPA filters. Um, HEPA filters have a MERV rating of 17, close to 17. It can filter out 0.3 micron particles too. So which overall, looking at a bigger point, it can stop 99.7% of impurities from the air. It can provide that much cleaner. Okay, and then we have so HEPA inclusion has become more post COVID, and then we have created electrostatic filters which can remove particulate matter. Also, particulate matter is very small, even less than 0.3 microns. So we give we use electricity to remove that particulate matter. So they electrostatic filters, the surface of the filters will come in contact with the particulate matter, and particulate matter will lie on to the electrostatic filter. That's how it will be removed. Okay, and then we have come up with UV inclusion into the systems which can kill the bacteria, and then we have included coating. The research is happening with regarding the coatings also, because the air that is entering in that space is staying in the unit before it enters the space, right? So the inside of the units has to be safe. So the surfaces, the air is conditioned, the bacterial growth can happen, and also um, so we have to arrest, I mean, like, we have to reduce that. So that's why we are trying to develop coatings which can reduce that. And then we use ionizers. Ionizers help to remove the suspended particles again, and along with that, it ionizers, basically they generate millions of negative ions into the space, into the air, which can hold on to the suspended matter, and then um, it'll weigh, it'll increase the weight, increase the mass, and it'll make sure it falls onto the surface. So that's how that's what it does. And also native ions is very good for human health. It increases the oxygen flow. It when it touches our body, it absorbs oxygen which is outside, and it will tend to flow inside our body when we take ions. Okay, because they'll be having it can attach to the oxygen. That is what it does. Okay, so uh, in the filters, I put a note. We have used activated charcoal, activated carbon, and then we have used fibers, catalysts, sieves. There are a lot of layers created, and there are a lot of different filters that came into the market, and this filter industry has grown a huge. Okay, every system must have high efficient filters. That is what the expectation from customer. Okay, Next slide. And then this is something which was majorly done in medical industry, and also people try to use it in homes also, but not all are doing this. We have created positive and negative pressure rooms, which are isolated wards basically. The working is very simple. The positive pressure, we tend to increase pressure inside the space wherever the space is. We have condition, we need to be safe. We'll increase the pressure high than outside. So as pressure inside is high, whatever air inside the room will tend to move out whenever there is an opening. For example, if there is a door, if someone opens the door, the air inside that positive pressure room will tend to move out. And what is the application of it? Why is it important? Is in medical places where a deceased person is treated in the space. Okay, yeah. So yeah, the space where deceased person is treated, there will have bacteria into the air over there. It has to move out automatically. We don't want that to be staying over there. So if we create high pressure over here and outside the negative than outside, it will tend to move out whenever the door is open. Okay, so we can make sure the air inside is clean. Okay, similarly negative pressure, negative pressure room is a similar thing, but when we have a person inside with the diseases, we don't want these contaminants going out. Okay, so that's why we create a negative pressure inside the room, so that inside contaminants will not move out. So okay, we will use forced we'll use ventilation systems to suck out the air which is contaminated, and we'll send it to a right space where it will be cleaned. So that's what we do. And then we have hybrid ventilation systems which use natural ventilation along with uh, yeah, natural ventilation along with forced ventilation. For example, if I have a room, if I have a home of 4 rooms, we'll have each we can mount wall ventilation systems onto each of the wall, which can suck out air into a common zone. In the common zone, we'll give opening on the top, so naturally it will go out. So we'll use combination. That's what we do. And major thing that changed with the ventilation system, another one is increased fresh intake. So earlier we were using a partial the return air mixed. Why do we mix? When we have we'll mix fresh air to the return air to make it dilute. If there is any pollutants inside, we want to make it dilute. That's what we do. Now they don't want to use the return air in some cases, so we have to change the design to maximize the fresh air intake. We want to reduce the usage of return air. So the design modifications have been done in the units to achieve that. Next one. Okay. Okay, so and now we increased control systems. We don't want to again as a part of COVID, we are used to not touch surfaces because of fear of contacting viruses. So we still want contactless controls and and we will use sensors to do the help. Okay, and we don't want to do maintenance physically, we want to do it remotely. We will be setting up systems which can do the remote maintenance. And then we want to, as data has become a major industry now, so we were utilizing data available uh, to become a smart for any technology. We'll be taking the data, and according to the data we are setting up controls to make it a smart system. So we have included the same in HVAC system also. We have collected, for example, if an office is run from 8 to 6, so the data is the data is collected, like within an year, for example, how many people are spending the time within these time zones. So based on that, the load will be calculated, the load will be expected. For example, if it's high on the afternoon, they'll be sending the system will send more cooling air into the space. If it is low, it will reduce. So the systems are becoming smart with data and IoT. So these are the again advancements included into the existing systems. And then one last topic I want to mention is this green buildings. People try to make their places a green certified habitats. So green certified habitat has certain characteristics to get that. um so they should the zone, the entire habitat should use renewable energy, and then it should use water within a limit, and it should use less energy, maybe usage of solar energy to be increased, and it has to. So we need to make the place to be sustainable, to stay in the earth for a long time. So this is something which most of the people trying to achieve. This is again a next level topic. I just want to mention it here so that we have this also as a part of building development. So then people are trying to look for certifications, well-known certifications for sustainable uh, uh, buildings. Okay, so these are the things people are concentrating on post COVID. Even for businesses, they are looking for lead and well. If they want, if anyone want to give businesses, they want to know designers who can do according to sustainable according to sustainable buildings. Okay, that's what I want to mention. Next, Mike. Okay, so that's it. My thoughts on what are the changes that has happened on what are the things that people uh, tend to adapt during COVID, and what are the changes HVAC industry wanted to bring, which uh, which included all the needs of the consumers. So this is what I observed, and this is what I want to share. Thank you all. Thank you all for your attention. Uh, if you have any questions, you can ask me.
Yeah, so thank you, Mr. Deja, for sharing your expertise. That was a very insightful presentation. And but due to the
I hope.
limited program time, so we were not able to answer all the questions during the live streams. So please
Okay.
comment, drop your comment, and the speaker will answer each question later. Okay, so
Okay.
it's like we cover all of the sessions. Is there anything else you want to cover before wrap up? Lisa?
Okay. I think I want to share all of these, but there is one more slide I added. Can you go to that slide? So, any technical discussion these days, can you move to the next slide, Mike?
Okay.
So, any technical discussion happening these days, we are all talking about AI, and I want to give it as a food for thought for the audience. So, we have AI advancements happening. We have a AI advancement happened, and we have seen the wonder of ChatGPT. So it has been the AI is getting into different systems very slowly. So it'll surely come into the HPC industry also. So for any enthusiast, so look into the AI. I mean, like look into the possibilities of AI included into the HVAC systems, which would help you for your future if you're enthusiast of HVAC industry. I would like to just give that food for thought. So guys can do a research on these.
Yeah, wonderful. Thank you. Thank you, everyone. We appreciate you are still being here. One more time, thank you, Mr. Poornateja, for your wonderful presentations.
Thank,
So,
thank you, my thank you, audiences. I hope you should. I gave some information for you to learn. Thank you. Thanks for the opportunity.
yeah, so hope that today's event will bring you useful knowledge. If you had interested in career opportunity as HCLTech, please visit our website and find out available job. So on behalf of HCLTech Vietnam and our presenters, thank you for joining us today. Bye. Thank you.
Thank you. Bye bye.